Greetings all, I'm Ali from Group 14. I'm here to present a presentation for Project STR and Project GEO. Here I'm going to begin with Project STR. Here we did a design for a pedestrian overpass bridge, which was spanning a road and railway tracks, which is located in Burnie in Tasmania. Here, the main key consideration for the project are the location, which is Burnie, Tasmania, which has a wind zone region A4. We also did use the applicable standards are AS 1400, 5100 series, and 1170 series. The structural members were provided to us using the building drawings. In that, it's top chord, bottom chord, vertical member, horizontal member, lateral brace, and horizontal brace. The dimensions for each of the structural members are given on the member schedule, top right of the presentation. The objectives of this project were to determine the loading conditions, imposed load, wind load, collision load, self load, dead load, conduct a static structural analysis for deformation and stresses, analyze the vibration characteristic and dynamic behavior, and provide design recommendations for structural integrity. First, we started by designing the model itself using Strand 7. The modeling was based upon the bridge drawings and Australian standards. We did then the load cases, each load calculations and load cases were calculated. Uh, Superimposed load, self load, live load, wind load, and collision load. Load combinations were as per AS 5100. For ULS and SLS, natural frequency analysis characteristics were also studied. These are the structural members and the dimensions and the material properties for each of them. And these are the loading conditions that we were taken into the account for the project. Now my other teammate will continue with the project. Thank you.
With two modeling. First of all, we did with the linear static modeling, in which we assess the structural behavior under different loading conditions, and we have ensured that deflection and stress remained within the allowable limits. And similarly, we have also done the natural frequency model, in which we have assessed the vibration impact on the bridge. In the linear static modeling, we actually did with the two model, ultimate limit state and the serviceability limit state, and a maximum and minimum fiber stresses are given here uh, under three load combinations. We, Similarly, we have also done the model with the natural frequency, and natural frequency is very critical modeling for understanding the vibration impact of structures. Similarly, we have used 8 mode, and the mode number 8 exhibited the best vertical acceleration in the project. These are some data that we got from the Strand 7 model, and you can see the mode number 8 gave us the best frequency results. For the design verification, we have used a simply supported model, which was actually a simpler version of the whole project. We have applied a 1.85 Pascal, a kilopascal load, and similarly linear static analysis with a 5 Newton per meter load. We have noted that the structural model and simply supported beam deflection result was not too much different, which validate our results. For uh, in the conclusion, we have achieved our static and dynamic analysis successfully, and similarly, natural frequency and dynamic behavior proved in the valuable performance insights. And for recommendation, the construction has to be done correctly according to drawings, and the laboratory test should be done to maintain material standards and workmanship quality.
My name is Usama Tariq. I'm going to explain the project GEO. This is my project, which is 14. In the introduction, actually, the finite element method is very important in geotechnical assessing solutions for accurately modeling complex soil structure interactions. In this project, we are using finite element method to assess the undrained performance of foundations in stiff clay soil under vertical loading with Strand 7 using as a software. So, two analyses include generating load displacement curves, stress strain relationships, and sensitivity studies on soil stiffness, ensure precise evaluation, optimize reliable design solutions. The main objective is to evaluate the foundation performance under vertical loading, focusing on load and displacement curve. The second one is developing and plotting stress strain curve for both the concrete material and for the soil. And the third one is conducting a sensitive study on the soil stiffness, where the Young's modulus will vary between 10 megapascal to 25 megapascal, and assessing the foundation performance across these variations. So the main problem is problem statement, which is being given to us, is the concrete foundation is modeled with the Young's modulus of 8,000 megapascal and a Poisson ratio of 0.15, and the surrounding soil, a highly resilient clay, is characterized using a linear, elastic, perfectly plastic model with specified 100 parameters, which are our group is being assigned the parameters, which is 21,000 kilopascal and 85 kilopascal respectively. The constitutive model chosen for the concrete is the linear elastic model. The model assumes that the concrete exhibits linear elastic behavior, meaning that its deformation is directly proportional to the applied stress within the elastic limits. With the help of the parameters which are being given, we calculated the shear modulus and the bulk modulus. For the constitutive model for the soil is modeled using linear elastic, perfectly modeled soil, which is suitable for describing the undrained behavior for stiffy clay. The chosen parameters were these. Undrained Poisson ratio was 0.49, so we derived the shear modulus, which is being given. Stress strain analysis to determine the stress and strain characteristics, a stress path based on the shearing stress will be considered. The mean effective stress and the shear stress at significant states such as starting point and the failure point will be calculated. From these values, the corresponding volumetric strains and the shear stress will also be determined. In the FEM process, FEM modeling process for foundation is very typically involves creating an FEM model with specific geometric and boundary conditions. Concrete has a Young's modulus of 8,000 megapascal and Poisson ratio of 0.15, where soil has a cohesion of 85 kilopascal. Young's modulus of 21,000 and Poisson ratio of 0.49. The model uses finite meshes around the foundations, applies uniformly vertical loads, and set boundary conditions at 4B from the foundation center. The goal is to generate a load displacement curve and accurately evaluate foundation behavior under undrained conditions.
Hi, my name is Satyashekhar Bhaskar Boruganti. I am from Group 14 and I will continue with the procedures for constructing FEM geometric problems. It is a step-by-step process where we have to develop a geometric problem using FEM using Strand 7 software. We have to create nodes necessary for the model and create elements from nodes. As you can see, we have to develop a mesh like this where we have to apply loads on the strip of the footing. Which we have chosen, and where we have to utilize the tool commands like coping, moving, extruding, subdividing, and other functions where we have to extend shapes, break elements to create the 3D model. For the importance of model integrity, it's important ensuring accuracy in simulations and consequences of flaws in the model, and also impact of geometric precision. For the FEM simulation expected results, we have three cases like EU is equal to 10 MPa, 15 MPa, 25 MPa for our project. In 10 MPa, we can observe greater deformation. In 15 MPa, we can observe moderate deformation. And in 25 MPa, we can observe least deformation for Young's modulus. For loads versus settlement curve, it's very crucial for determining footing performances and summation of vertical reaction forces at nodes and displacement control analysis, which is given by P is equal to FIP summation. For the validation of results for ultimate bearing capacity, we have theoretical bearing capacity calculation example where formula is NC is equal to 2 plus pi Cu and NC is equal to 5.14 into Cu. where given as CU and NC will be in pascals. And through FEM bearing capacity, we have zero point 0.5 into PU, where PU is computed value from FEM, and where effective length LFEM will be length of footing plus zero point 0.5 into length of adjacent element. For the comparison of results, we have to compare by taking out ratio of NC FEM by NC. In conclusion, if the result is almost equal to 1 or should closely matches the theoretical value, then this correlates the validation and the result will be acceptable and reliable. Thank you very much.